Hello, today we learn the OSI model in networking. OSI model in networking is very important. There is some layer like layer 1, layer 2 to till layer 7, that is your physical layer to application layer. So there is a first is a physical layer, then is a data link layer, then network, then transport, then session, then presentation and application. So classify how application device and protocols related to the OSI model layers like IP, address, frames, packets and cables. So we'll just brief about this objective of this OSI model. So OSI stands for Open System Interconnection. This is the full form, Open System Interconnection, like created by International Standard Organization. So was created as a framework and reference model to explain how different networking techniques work together and interact. So it is not a standard that networking protocol must follow. What is the OSI model look like? This is the layer form that we can show about this picture, that is physical, then data link, then network, then transport, session, presentation layer and application layer. So all layers work together in the correct order to move data around in network. So this is important to move physical to application. We can't split any and we can't forget any layer in between that. So we have to summarize all the things sequentially. So OSI layer model mnemonics means top to bottom. All people seems to need data processing. So this is the top to bottom mnemonics, and bottom to top, please do not throw Shaw's pizza away. Okay, so this is the two method to learn these things. If you are learning by this name, it's very sufficient for that. So what is the encapsulations and de-encapsulations? The process of moving data between layers of the OSI model. So encapsulation means data segment, like physical layer is generally send your data into bits form to the data network. Data network generally works on the that bit form into the frame and send to the network. Network layer generally convert the frame into the packets, send to the transport, and transport layer convert that packets into segments, and then segments sent to the session layer. Session layer that's work on their segment to data. So these three above layers will generally work on the data part. So data, segment, packets, frame and bits. So bits sending to the it's a frame, frame sending to the packet, packet sending to the segment, segment sending to the data. De-encapsulation means opposite to this. Like firstly data sent to the segment, segment into packet, packets data, and data into packets into frame, frame into bits. So encapsulation means physical to application, de-encapsulation means application to physical. So how data is referred to in the OSI model? So data means application, presentation and session layers. Okay. Segments means your transport layer, you are transporting your data. Packet means your networking. Frame means data link layer, and bits means your physical layer. Physical layer of OSI model deals with all aspect of physically move data from one computer to the next. Convert data from the upper layer into ones and zeros for transmission over media, like bits format 0 and 1. Define how data is encoded onto the media used to transmit the data. Define on this layer cable standard, wireless standard, and fiber optic standard. Physical layer of OSI model, that is device example like your hubs. Hubs generally sending your bits format to the computer, your data used to transmit data. So copper wiring, fiber optics cable, radio frequencies, anything that can be used to transmit data is defined on the physical layer of the OSI model. Then is your data link layer. Data link layer is responsible for moving frames, like your bit format changing into the frames for node to one computer to the next computer. Can move frames from one adjacent computer to the another. So can't move frames across router. Encapsulation equal to frame. So we already read about this, like encapsulation and de-encapsulation. Required MAC address or physical address for your data link layer. Required for MAC address and physical address. Protocols defined include in Ethernet protocol, point-to-point protocol. Okay. Data link layer, device like switch and two sublayers, logical link control LLC and the media access control MAC. So what is the logical link control and media link control? This is the data link layer part. So logical link control means data link layer addressing, flow control address, notification, error correction. So this is your logical link control. MAC generally determines which computer has access to the network media at any given time. Determines where one frame ends and the next will start. Call frame synchronization. Okay, this is the MAC and LLC. Then your network layer. Network layer is responsible for moving frames into packets from one input of the network to the another end, called end-to-end communication. Required for logical address such as IP address. Devices example your routers. Routing is the ability of various network, device and their related software to move data packets from source to destination. Then your transport layer. Transport layer generally convert your data into the segments, like your frames into segments. Sorry, packets into segments. So segment that can be sent to lower level layer for data transmission. So conversely, reassemble data segments into data that higher level protocol and application can use. So also put segment into correct order called sequencing. So they can be reassembled in correct order at destination. Then your transport layer of OSI model means concerned with the reliability of the transport of sent data. May use connection-oriented protocols such as TCP to ensure destination received segment. May use to connection-less protocols such as UDP to send segments without assurance of delivery. So whenever we generally connection-oriented, that is we are using the TCP, and connection-less protocol we are using the UDP. Okay. Use port addressing. Session layer. Session layer is responsible for managing the dialogue between networks and devices, stabilizing, managing, and terminates connections. Provide duplex, half duplex, and simple duplex communication between devices. And provides procedure for stabilizing checkpoints, adjustment, terminations, and restart or recovery procedures. Presentation layer of OSI model means, firstly we have to understand duplex, full duplex, and half duplex. Half duplex means your connection is going to the source and destination, only one connection, like one direction is only. Duplex, half duplex. Like 1 minute. First is your duplex. Duplex means your data starting from source and destination is going only one direction we have to give in. Half duplex means your connection is data is here and start from the source node to last node. There is some data in between that. and both side data connected to each other. They can send data, but it will receive it and it will connect it. But in simplex communication, so it receive and it transmit data. But in duplex format is only duplex format means generally sending data and receiving data simultaneously. But in half duplex, we can send data, but we can't receive in half duplex. Like source is sending data to the destination, but destination can't send that. In duplex form, source is sending data to the destination also sending data to the duplex, that is a receiving and transmitting format. Presentation layer. Concerned with low data is presented to the network handles. Their primary task is to translation, compression and encryption. Presentation layer of OSI model. Translation means changes data so another type of computer can understand that. Compression means make data smaller to send more data in same amount of time. Encryption means encode data to protect from interception or inad application layer of OSI model. Application layer of OSI model is like contains all services or protocols needed by application software or operating system to communicate on the network. For example, Firefox web browser uses HTTP like a hypertext transfer protocol. Email program may use POP3 means Post Office Protocol version 3 to read emails and SMTP simple mail transport protocol to send emails. Then how data moves through the OSI? First we have to understand this is chart we have given. That is like firstly data is operating system, data present, then giving to the application layer. That is application header. Application header and presentation layer going on working on the data. Then your session layer going on. Session layer generally working on your what? Segmentation. No, segmentation working on your transport header. Then your packet in network. Then frames in data and physical, that is your bit. So this is the diagram. How data moves through the OSI model content. Each layer of OSI model except physical add its own header to the data that originated from the operating system. Adds own header in front of header from the previous layer. Header contain information that describe what each layer of the OSI model should do with the data. Data link layer also adds a trailer. Trailer contains additional information that deals with error and correction. Data as it's appeared to operating system, so that is data link layer and so connection. So data move OSI layer sent by one computer and received by another. This is I'm sending data and receiving side is also this is sending information and this is the receiving. Receiving means physical to application. Sending means application to physical. TCP/IP protocols. Build around the TCP/IP protocol suite. Protocol suite is a large number of related protocols that work together to allow networks computer to communicate. Okay, that is there is a 4 layer present in TCP/IP only. First is a network interface layer because your data physical and network thrice represent in your network interface layer. Okay, second is the internet layer and then your transport layer, then your application layer. So session layer, presentation layer, and application thrice are present in your application layer. TCP/IP model, like layers with same name as the OSI model, don't function exactly the same. So we can see here data link layer and physical layer both are network interface layer. Network layer is your network layer. Transport layer working on the simple transport layer. Session layer, presentation layer, and application thrice are working on the application layer. So in OSI there is a 7 layer, in TCP there is a 4 layer. So application layer encompasses some same functions as these OSI model layer, application, presentation, and session layer. What they generally do working on the data. Transport layer functions the same as the transport layer in OSI model and part of the session layer. TCP can other similar protocol take on some of the function of the session layer, like synchronize source and destination computer to set up the session between the respective computers. Internet layer perform same function as OSI network layer. Many of the function of logical link control sublayers of OSI model data link layer. Primary protocol is the internet protocol. Also uses address resolution protocol, which performs much of the LLC sublayers job in the area of physical addressing. Interface layer of TCP/IP model means perform much of the job of MAC portion of data link and physical layer of the OSI model. The TCP/IP protocol does not detect what happens on the network interface layer. TCP/IP protocol should rely on the standard created by the various standard organization concerning how to encode bits onto media to do the network on this layer. Alternate layer, like COM-TIA network plus objective recognize alternate layer names for last layer in TCP/IP model, the link layer. Link layer, that is a network interface layer. Internet layer, transport layer. Okay. So how the layer work together? Different protocol located on the application layer of the TCP/IP model connect to different transport layer protocol. Exception: DNS protocol on the application layer connect to both TCP transport control protocol and UDP user datagram protocol. So protocols on the transport layer. Application layer generally work on the SMTP, FTP, HTTP, that is your TCP. UDP generally work for DNS, TFTP, RIP, and SNMP. Okay. And TCP working on the ARP and RP, and that is your IP address, and IGMP, ICMP. And network, that is your Ethernet 802.11 wireless network, frame relay, ATM, that is. So this is all about this thing. So I hope you understood it, and this is by my side for awareing this topic is very important according your exam and according your some competitive exams also to related in computer science. So that's the thing. So this is my side.